All right, y'all, quick video here on the chain rule. Thanks for being flexible today. So the chain rule comes as a rule after all of our other rules we've looked at with so far. Power rule, product rule, quotient rule, trig functions, constant multiple rule. Now we have the chain rule. It lets us differentiate composite functions like root of something else besides x, where the root is the outer function, and then 3x plus 4 is the inner function. And then here, sine of something is the outer function, and then the inner function is sine of x cubed. So when you do that, like if this were g is equal to sine of x, well, then the derivative of sine of x is cosine x. But when the input is something other than just x, you need more to the story. A composite function is written as f circ g of x, or I don't like that notation very much. I tend to like this one. And when you take the derivative of a composite function, then it turns out to be this. This is carrying out the chain rule, where you take the derivative of the outer function, you leave the inner function inside of it alone, and then you're going to multiply all the time by the derivative of the inner function. So here on this one, let's see, we have an outer function, something to the 4, and then we have this inner function, 5x squared plus 11x. So when we differentiate, let's use that color. So y prime, it'll be the derivative of the outer function. So we bring the 4 down. We raise it to the power 3 for the power rule. So 4 down, bring the 4 down, raise it to the power 3, and then we repeat the inner function, and then times the derivative of the inner function, 5x squared plus 11x. All right, so here we have, we've differentiated the outer function again, was something to the 4. So in something to the 4, you're going to use the power rule. So the 4 goes down to the front. We subtract 1 off the exponent, repeat the inner function, and then multiply it by the derivative of the inner function. And so if we continue on, we would get y prime is equal to the 4, the 5x squared plus 11x cubed times, and then now the derivative of inner function using whatever rules you would use. This one, let's say we have 2 terms, so we're going to take the derivative of each term, and 5x squared, we'll use the power rule, 11x power rule, constant multiple rule, so we end up with 10x plus 11. There's our derivative. The next one, we have an outer function, sine of something. We have an inner function, 3x squared plus e to the x. So let's differentiate. We have the derivative of the outer function. That's cosine. Sine goes to cosine. We repeat the inner function and then multiply by the derivative of the inner function. So y prime, it's going to give us cosine of 3x squared plus e to the x times 6x plus e to the x, where 3x squared differentiates to 6x and e to the x differentiates to itself. It's like the chain rule is like measuring cups. Let's say you have a measuring cup, and then you have another one inside of that, and then you have another one inside of that, and another one inside of that. You have a bunch of cups stacked inside of each other, and when you differentiate this, you take the derivative of the outer piece and you leave the inside pieces alone, and then you go to multiply by the derivative of the inner function. When you do that, you peel off the outer layer and you just look at the next inside. It's like an onion. You differentiate the outermost layer with the inside layers left inside, then you peel off the outer layer, then you have a new onion, the inside of the onion, and then you differentiate that, and then you peel that layer off, and then you differentiate the inside of that. That's how that works. Let's look at this next one. Y equals 7e to the 3x to the 4. Y prime. Let's see. We have a constant multiple, 7. So our derivative would be 7 times the derivative of e to the 3x to the 4. Then, so it's 7 times. Then the derivative of e to something. E to the 3x to the 4. E raised to an exponent, that's your outermost function. The inside function, or the inner function, is the function in the exponent. So because it's the exponent where e takes its input. If the function f of x was e to the x, then e to the x is the outside function, and the inner function goes there in the exponent. So our 3x to the 4 is the inner function. So how does that differentiate? E to something differentiates to itself. E to the 3x to the 4, that's the derivative of the outer function times the derivative of the inner function. That's using the chain rule. So this is 7 times e to the 3x to the 4 times 12x cubed. There you go. You can multiply now the 7 and the 12 and combine those, but I'm just going to leave it like this. I think this is the now we got 2 more. Okay. Outer function is the root of something. Inner function is this x plus 1 divided by x plus 2, for which you would need the quotient rule. So f prime x. Derivative of the outer function, we know the root of something differentiates to 1 over 2 root of the inside function. So 1 over 2 root of the inner function times the derivative of the inner function. So we have 1 over 2 root x plus 1 divided by x plus 2 times, and then now for differentiating this, we need the quotient rule. So let's do that. Low function, d high, which is 1, minus high function, d low, which is 1, all over low squared. There you go. There's your derivative. You could simplify this some, but I'm not going to deal with that right now. Then the next one, we have 2 terms. So we have this term and this term. We're going to differentiate each term separately and identify inner and outer functions. This first term, we could write it as cosine of x, all of that raised to the 4. So we have an outer function of something to the 4, and we have this inner function cosine x. On the next one, we have an outer function of cosine, an inner function of x to the 4. So when we go differentiate on the cosine x, all of that raised to the 4, we use the power rule. 4, bring down the 4, subtract 1 from the exponent, repeat inner function, times derivative of inner function. Plus, now we need to go differentiate this next piece. Cosine differentiates to negative sine, so our outer function would become differentiate to negative sine with the inner function left alone times inner function derivative. Let's see if we can move that. There we go. So let's keep going. This is a 4. Let's write it as 4 cosine cubed x times. Now we have the derivative of cosine, that's negative sine. Then we have minus sine of x to the 4 times derivative of x to the 4, that's 4x cubed. There you go. There's your derivative. The, I think, tricky part with the chain rule is figuring out what's an inner function, what's an outer function, and then carrying out the rule. We'll work on this more on Tuesday with implicit differentiation, but for now, this is the chain rule. All right. Thanks for watching. Please reach out with any questions. See you all soon.